In this video lesson, we are going to learn how to construct the following inscribed inside a circle: a square, an equilateral triangle, and a regular hexagon. So let's go ahead and get started. We are first going to go ahead and start with a square inscribed inside a circle. So what I need you to make sure you have are your construction tools, so your compass and your straight edge. So the first thing that I'm going to do is I'm going to take my straight edge and I'm going to go ahead and just construct a segment. Doesn't matter how long the segment is, just go ahead and construct a segment. I'm going to make sure that I put endpoints on my segment. Now, from those endpoints, I'm going to go ahead and construct the perpendicular bisector. So remember, you're going to go ahead and take your circle jar, you're going to put it at one of the endpoints, make sure that it's bigger than halfway, so you want to make sure that it extends past the midpoint mark. And I'm going to go ahead and make a mark above and below my line. Now I don't want to change the measurement. I'm going to take my compass and I'm going to take that same measurement and I'm going to go ahead and take it to the other vertex without changing the distance here. And now what I'm going to do is I'm going to go ahead and make that same arc. So what should happen is that those arcs should cross. I'm going to go ahead and take my straight edge and I'm going to go ahead and connect those arcs. I have to adjust mine here so that I have a line that passes through them. So what I've done is I've constructed the perpendicular bisector. And so now this center point where they meet, well, that is the center of my circle. So I'm going to take my compass and I'm going to put the point at the center of the circle. And then I'm going to go ahead and I'm going to measure out to one of my endpoints of my segment. So what that becomes is that's the new radius of my circle. So from there, I'm going to go ahead and draw a circle. It should hit the other side and all the way around. So there is my circle. So my job was to go ahead and construct a square. Well, the vertices of your square are going to be the two endpoints of your original segment. And then when you constructed that perpendicular bisector, the 2 points and when that crosses the circle. So take your straight edge, and we can go ahead and draw lines to connect my vertices. And there you go. We have constructed a square inscribed inside a circle. All right, so let's do another one. So the first thing I want you to do, and we're actually going to be able to construct an equilateral triangle as well as a hexagon, all within the same construction. So I just need you to draw a circle. Now remember, don't forget the length of your radius. And I'm going to put the center here. I'm going to put a dot at the center so I know where that is. And I'm going to go ahead and draw my circle. Okay, so there's my circle. Now keeping that length of the radius, I'm going to take my compass and I'm going to start, it doesn't matter where you start, but I'm going to put the point of it somewhere on the edge of the circle. And with my compass, I'm going to go ahead and make a mark on the edge of my circle. Now from there, I'm going to take my compass and I'm going to put the point where I made that mark. And I'm going to make another mark. And I'm going to go all the way around my circle. So I'm going to come back to that point. And I'm going to make a mark on my circle. I'm going to come back. I'm going to make another mark. I'm going to come back. Oops, let me fix it first. And make a mark. Go back to that point. Make a mark. And what you should find out is that you will end up going around your circle exactly 6 times. And let's think about why that works. If I were to go ahead, this was the center, and if I were to go ahead and construct those two radii, well, since they're radii, I know they're the same length. And I also know that the distance from arc to arc is also the same as the radius. So really, I've constructed what type of triangle? Right, all the sides are the same, which means I've constructed an equilateral triangle. Well, since I've constructed an equilateral triangle, I know all the angle measures are 60 degrees. And if all the angle measures are 60 degrees, well, if I keep going around my circle, how many 60 degrees make up 360? So think about that. 360 divided by 60, well, that's 6. So it makes sense that the radius of a circle divides its circle into 6 equal arcs. So let me get rid of that. Okay, well, to draw my hexagon, all I'm going to do is I'm going to take my straight edge and I am going to connect each of the intersecting arcs. And I know that length that I just drew is the same length as the radius. I know all of these lengths are going to be the same. And so we have just constructed an equilateral hexagon, or a regular hexagon, I should say, inscribed inside a circle. Now, if I were going to go ahead and construct an equilateral triangle inscribed in a circle, I'm going to go ahead and use those same tick marks. But instead of connecting consecutive tick marks, I'm going to connect every 2 tick marks. So if I start up here at the top, I'm going to connect down here. Then I'm going to skip one and go across, skip one, and come up again. And there I've constructed a regular or an equilateral triangle inscribed in a circle. So there you have it. There's how we can do some constructions involving circles.